In this lesson, we're going to show you two strategies for simplifying complex fractions. The first strategy requires that you think of the numerator and denominator of the complex fraction separately. So you think of this numerator as its own entity and this denominator as its own entity. After each one is as simplified and summed and differenced as much as it can be, then you'll work to combine the two of them together. Now we can see, obviously, that this numerator is already in its most simplified form, 3 over x plus 5. But this denominator, going back to previous lessons, we can create a common denominator for this larger denominator of x minus 3x plus 5. We don't need, in method number 1, we don't need to worry about the numerator. We are worried only about the denominator. So here, we're going to give the first fraction that common denominator by multiplying it by x plus 5. And we're going to give the second fraction that common denominator by multiplying it by x minus 3. Now, because these two fractions in the denominator have the same denominator, we can sum the two of them together into one rational expression. Now, in order to do that, we're going to have to do a little bit of pre-algebra, algebra arithmetic work here. 2x plus 10, 1x minus 3. We're adding the two of those together. That simplifies to 3x plus 7. And all of that is still under 3 times x plus 5. So the simplified version of this denominator, once all added together, becomes 3x plus 7 over x minus 3 times x plus 5. Right here, available to us now, is a division of rational expressions. So we can keep our numerator the same, and we can multiply by the reciprocal of the denominator. And it's in this step where you're going to do your last bit of simplifying work. X plus 5 simplifies with the x plus 5, and we are left with 3 times x minus 3 over 3x plus 7. We want to give special consideration and a reminder that if we were to evaluate this expression, we would not be able to evaluate it at 3 and negative 5 because of the role that the denominator played up here. So walking through method 1 one more time, if a numerator or a denominator is already its own rational expression, it can just stay the way it is. In the event that you have two fractions that you need to find the sum or difference of, you identify their common denominator and work with that common denominator to simplify it as much as you can. Once you have a fraction over another fraction, you can multiply by the reciprocal of that denominator and simplify using our same techniques. Notice that nothing got multiplied out. I didn't change this product right here to its trinomial form. I left it the way it was because we knew we wanted to cancel with the x plus 5. Method number 1 requires you to look at the numerator and denominator separately, treat each of them as their own sum or difference, and then bring them together using the division of rational expressions.